In 1 through 12, we're naming the point that corresponds to each polar coordinate pair, or each ordered pair. Remember, they're in the form r comma theta. And so in number 1, we have 3 comma 120. What I'm going to do is I'm going to find the 120 degree radial line, or the 120 degree ray, and travel out 3 units from the origin, and we'll be at point D. For number 2, we have 3 comma negative 45 degrees. So for this one, we're going to rotate negative 45 degrees, which will be in a clockwise direction from the positive x-axis. So there's negative 45 degrees, and then 3 units out from the origin brings us to point K. For number 3, we're going to find the 180 degree ray, and on that ray we're going to travel in the opposite direction because the radius is negative 3. So I'm going to back up and go in the opposite direction 3 units, and so that's point I. For number 4, 3 comma negative 270, I'm going to rotate negative 270 degrees. So if I rotate negative 270 degrees, that will be in the clockwise direction. There's the negative 270 degree spoke. 3 units away from the origin on that ray is at point E. For number 5, we need to rotate to positive 420 degrees. So that's 360 degrees plus an extra 60 degrees. And then 3 units away from the origin there is point F. For number 6, we have a negative 135 degree rotation. So if I rotate negative 135 degrees, that brings us to that radial line. And the radius is negative 3, so it's in the opposite direction, which brings us to point G. For 7, we have the point 3 comma 360 degrees. So I'll use a positive 360 degree rotation. 3 units away from the origin is point I. For number 8, we have a 30 degree rotation, but the radius is negative, so we're going to go in the opposite direction to point P. Oops, that's number 8. For number 9, we have a 225 degree rotation. 225 degrees brings me to this point right here. And our radius is negative, so we're going to go in the opposite direction, which brings us to point G. For number 10, the angle is negative 30 degrees, so that's a clockwise rotation by 30 degrees. And the radius is negative 3, so it's in the opposite direction, which brings us to point B. For number 11, the angle is negative 45, so that's a rotation from the positive x-axis in a direction clockwise by 45 degrees. And the radius is negative 3, so we go in the opposite direction to point C. For number 12, our angle is negative 300, so I'm going to rotate from the positive x-axis in a direction clockwise by 300 degrees, which is 270 plus an extra 30 degree rotation. So that brings us to this radial line at negative 300 degrees. And the radius is negative 3, so I'm going to go in the opposite direction, 1, 2, 3, to point N. In 13 through 16, we're converting from polar, which is r comma theta, to rectangular, which is x comma y. So we know that x is equal to r times the cosine of theta, and r is 12, and theta is 45 degrees. The cosine of 45 degrees is the square root of 2 over 2, So if we simplify, that's 6 times the square root of 2. The y value is equal to r times the sine of theta, and that's 12 times the sine of 45 degrees. The sine of 45 degrees is also square root of 2 over 2, so that simplifies to 6 root 2. So that means the x comma y that we converted to is 6 root 2 comma 6 root 2. For number 14, again, we are given r comma theta, and we're trying to convert that to a point in rectangular form x comma y. X is equal to r times the cosine of theta, which is 2 times the cosine of 120 degrees. And the cosine of 120 degrees is negative a half. 2 times negative a half is negative 1. Y is equal to r times the sine of theta, which is 2 times the sine of 120 degrees. And the sine of 120 degrees is the square root of 3 over 2. 2 times the square root of 3 over 2 is the square root of 3. So this r comma theta converts to negative 1 comma square root of 3 in r theta form. In number 15, we're trying to convert from r comma theta form to x comma y form. X is equal to r times the cosine of theta, which is 6 times the cosine of 210 degrees. And the cosine of 210 degrees is negative square root of 3 over 2. So 6 times a half is negative 3, so that gives us negative 3 times the square root of 3. The y value is r times the sine of theta, and that's 6 times the sine of 210 degrees, which is 6 times negative a half, or negative 3. So in x comma y form, negative 3 root 3 is the x coordinate, and negative 3 is the y coordinate. In number 16, we have an ordered pair in the form r comma theta. Convert to x comma y. So x is equal to r times the cosine of theta, which is 5 times the cosine of 270 degrees. And the cosine of 270 is 0. So 5 times 0 is 0. Y is equal to r times the sine of theta. And our r value is 5. And theta is 270 degrees. The sine of 270 degrees is negative 1. So the y value is negative 5. So in x comma y form, this is 0 comma negative 5. In 17 through 20, we're converting from rectangular x comma y to polar r comma theta, but we're going to make sure that our r value is positive and our theta value falls somewhere between 0 and 360 degrees. In 17, we are presented with x comma y, and we're trying to convert to r comma theta. R squared is equal to x squared plus y squared will help us find the r value. And if x is negative 6 and y is 6, then r squared is 36 plus 36, or r squared is 72. And when we take a square root and simplify that, that will be 6 times the square root of 2. To find theta, tangent of theta is equal to y over x, and that's 6 over negative 6, which is negative 1, so tangent of theta is negative 1. We know that tangent is negative whenever we're in quadrant 2 or 4. In order to narrow it down, we have to ask ourselves where this original point was. When the x value is negative and the y value is positive, that's going to be a point in quadrant 2. So when we answer the question with the theta value that is has a tangent of negative 1, we're going to find the theta value that's in quadrant 2. And when tangent is negative 1 or negative 1 over 1, that's a 45-degree reference angle, so that's 135 degrees. So our r comma theta is the point 6 times the square root of 2 comma 135 degrees. In number 18, we are presented again with x comma y and want to convert to r comma theta. R squared is equal to x squared plus y squared, and x is 5, and y is negative 5 times the square root of 3. 5 squared is 25, and 5 times the square root of 3 squared is 75. So r squared is equal to 100, and if we take the positive square root of that, r is equal to 10. Tangent of theta is equal to y over x will help us find the value of theta. And y over x is negative 5 root 3 over 5, which equals negative root 3. Tangent's negative in either quadrant 2 or quadrant 4, but before we attempt to answer this one, we know that the original point x comma y has an x value that is positive and a y value that's negative. That means that that point is in quadrant 4. So when we find the theta value, we're going to pick the one that's in quadrant 4. So tangent of theta is equal to the square root of 3 gives us a 60-degree reference angle. But in quadrant 4 with a 60-degree reference angle, we are at 300 degrees. So that means in r comma theta form, this is 10 comma 300 degrees. In number 19, we have an x comma y, and we're going to an r comma theta. R squared is equal to x squared plus y squared. And the 3 squared is 9, and the square root of 3 squared is 3. So that means that r squared is 12. When we take a square root and simplify it, that's 2 times the square root of 3. We're picking the positive square root, of course, since we want an r value that's positive. The tangent of theta is equal to y over x, and that's equal to the square root of 3 over 3. Now, you can unrationalize this for purposes of a reference triangle, and opposite over adjacent is 1 over root 3. Our original point is a point where x and y are both positive. So although there are 2 quadrants to pick from, we're going to pick the quadrant 1 angle. So if tangent of theta is 1 over the square root of 3, then theta must be a 30-degree angle. So in r comma theta form, this is 2 times the square root of 3 comma 30 degrees. Number 20, r squared is equal to x squared plus y squared. X is negative 7 and y is 0. So that gives us 49 plus 0. So if r squared is equal to 49, then the positive square root is 7. So r must be 7 if we want r to be positive. The tangent of theta is equal to y over x, and the y value is 0 and the x value is negative 7. So that means the tangent of theta is equal to 0. Remember that tangent represents slope, and the slope of a horizontal line is equal to 0. So we're looking at our horizontal rotations, which are 0 degrees and 180 degrees. We need to think about when our x value is negative, we're going to be on the left side, so that rotation will be 180 degrees. So in r comma theta form, this is 7 comma 180 degrees. In 21 through 26, we're completing a table of values and graphing on the indicated interval. So if I have the equation r is equal to negative 4, and we're graphing from theta equals 0 to 180, r is just always negative 4. And now we can graph each of the points. So if I rotate 0 degrees and then go in a direction that's negative, I'm going to put that first point over here. And then if I rotate in the direction 30 degrees and go in the opposite direction, 4 units, it's going to be over here. 60 degrees and negative 4. rotate negative 90 degrees and go in a negative direction from there. 120 degrees, negative 4. 150 degrees, negative 4. 180 degrees, negative 4. So if I start there and stop there, we have that half circle that we've just graphed. In number 22, theta is always 150 for r between negative 4 and 2. So all my theta values will be 150, and the r values will vary from negative 4 all the way to 2. Let's start with 150 degrees and a radius of 2. Here is a 150 degree rotation. And so 2 units out is right there. 1 unit out is right there. 0 units is right there. And I'm going to keep going. Negative 1, negative 2, negative 3, negative 4. So the graph goes from negative 4 to 2. So the graph is just simply going to be a line segment. For number 23, r is equal to 6 minus 1/60th times theta for theta between 0 and 360 degrees. So this is a linear function. You can see that we have a slope, negative 1/60th, and a y-intercept of 6. Of course, it's not going to graph like a line, so we need to fill out the table of values. 6 minus 1/60th times 0 is 6. 1/60th times 60 is 1. 6 minus 1 is 5. 120 times 1/60th is 2. 6 minus 2 is 4. And so every time theta increases by 60 degrees, the r value is going to decrease by 1. So if we start at 0 degrees with a radius of 6, at 60 degrees the radius is 5. At 120 degrees the radius is 4. So far the graph is spiraling inward. And then at 180 degrees the radius is 3, continuing to spiral inward. 240 degrees the radius is 2, continuing to spiral inward. At 300 degrees the radius is 1, again spiraling inward, and at 360 degrees the radius is 0. For number 24, we're going to get a similar spiral. 1/90th times 0 is 0. 1 plus 0 is 1. 1/90th times 45 is a half. So at 45 degrees, the radius is 1.5. At 90 degrees, the radius will be 2. So every time we increase the theta value by 45 degrees, the radius increases by a half. And now we can graph those points. At 0 degrees, the radius is 1. At 45, it's 1.5. At 90, it's 1. At 135, at 90, the radius was 2. And at 135, the radius is 2.5. At 180, the radius is 3. At 225, the radius is 3.5. And at 270, the radius is 4. We're only going from 0 degrees to 270 degrees, so when we connect those, we get a nice little spiral. For number 25, we have a little bit of help with our theta values from 0 to 270, and we can find the sine values first. So the sine of 0 is 0, sine of 30 is a half, sine of 90 is 1, sine of 150 is a half, sine of 180 is 0, sine of 210 is negative a half, and sine of 270 is negative 1. So the r value is 2 minus 2 times the value of the sine, which is 2. 2 minus 2 times the value of the sine is 1. 2 minus 2 times the value of the sine is 0. 2 minus 2 times the value of the sine is 1. And 2 times minus 2 times the value of the sine is 2. And 2 minus 2 times negative a half is 4. And 2 minus, I'm sorry, that's 3. 2 times negative a half is negative 1. And 2 minus negative 1 is 3. 2 minus 2 times negative 1 is this time 4. All right, so at 0 degrees, the radius is 2. At 30 degrees, the radius is 1. And at 90 degrees, the radius is 0. We're spiraling inward. Now at 150 degrees, the radius is 1. And at 180 degrees, the radius is 2, again spiraling outward. At 210 degrees, the radius is 3, continuing to spiral outward. And at 270 degrees, the radius is 4. So for number 26, we have to multiply the theta values by 3 first. 0, 60, 90, 120, 180, 240, and 270. And then we have to multiply 4 times the cosine of those values. And the cosine of 0 is 1. The cosine of 60 is a half. And the cosine of 90 is 0. Cosine of 120 is negative a half. Cosine of 180 is negative 1. Cosine of 240 is negative a half. And cosine of 270 is 0. All right, let's graph our points. When our theta is 0, the radius is 4. When theta is 20, the radius is 2. So that's not quite to the 30-degree mark. When theta is 30, the radius is 0. Now, when theta is 40 degrees, so that's not quite to the 45-degree mark. If we're thinking about where that is, 40 degrees should be about there. The radius this time is negative 2. So that means that our point will be located about there. And then when we're at 60 degrees, the radius is negative 4. So that points in the opposite direction from the 60-degree rotation. So we're spiraling outward there. And now when theta is 80 degrees, about there, the radius is negative 2. That's in the opposite direction. So now we're spiraling back inward. And then at 90 degrees, the radius is 0. So again, spiraling back inward. What we started here is part of a 3-petaled rose curve. In 27 through 30, we're asked to write the equation of each sinusoid. First thing I might draw attention to is that vertical shift, or new x-axis, is negative 1 for this function. The amplitude of the sinusoid is 4. And this is a sine function because it starts in the middle, goes to a peak, then back down to the minimum and back to the middle again. And that's a right side up sine function. So its equation is y is equal to 4 times the sine of x minus 1. In number 28, again, we have a vertical shift. So the middle of the function is right there at positive 2. The amplitude of this function is 3. But if we trace the cycle, it goes from minimum to minimum, which makes this an inverted cosine. So y is equal to negative 3 times the cosine of x plus 2. In number 29, we'll notice there's no vertical shift, but we have a change in the period of the function. So let's sketch one cycle or highlight one cycle here. I'm going to notice that this is a peak to peak, so that's a cosine, but the period is 120 degrees. So 360 degrees divided by b is equal to the period. So that must mean that b is equal to 3. And the amplitude of our cosine function is 2. So y is equal to 2 times cosine of 3x. All right, let's take a look at number 30. In number 30, there again is no vertical shift. And if we highlight one cycle, this looks like a sine curve because it starts in the middle, but it's going down first. So that must mean it's an inverted cosine. I'm sorry, an inverted sine. Our amplitude is 5. So we know we're going to start with y is equal to negative 5 times the sine of, and now we have to account for the period. So 360 divided by the b value is equal to the period 180. That means that b must be 2. So this is y is equal to negative 5 times the sine of 2x.